Hello and welcome to Fresh Thinking by Snowden Optiro. My name's Tarrant Elkington, General Manager. The topic for this podcast relates to Trolley Assist, an old technology that has seen some application in the mining industry in the past few decades and may well become more relevant in the future as the world looks to electrify and decarbonise. For this discussion, I am joined by Sarah de Vries, who is a principal consultant with our mining team here in Australia. Sarah has over 15 years of experience in open pit and underground mining, with a focus in the last 8 years on mine electrification. Thanks for joining us, Sarah.
Thanks for having me.
So firstly, Sarah, maybe you could just start by explaining to us what Trolley Assist is.
Trolley Assist is just like the trains or trams you see in most capital cities. So a typical mining truck, instead of running off diesel, will raise a pantograph up to connect with the overhead electric line, and it will draw electric power straight from that line. So the diesel engine will switch off and it will run straight on power. This is great because, one, you get a huge speed advantage coming up the ramp out of a pit, so almost double. And you also save about 90% of your diesel consumption while you're connected to the overhead trolley. So it's great, particularly in, traditionally it's been used in areas that have very cheap power, so hydropower, or countries that have difficulty getting diesel into the country, such as South Africa in the 1970s.
Absolutely. So, and what's your experience with this technology?
I was fortunate enough to work at 2 mines in Zambia that used Trolley Assist. I worked at Kansanshi Mine and Sentinel Mine. Kansanshi had used Trolley Assist for about 5 years before I started there, and I was involved in designing new trolley ramps, helping with the project implementation, and ensuring good operational results from those Trolley Assist trucks. I was also fortunate to spend a year at Sentinel Mine in the middle of that time at Kansanshi. We managed to commission the first Liebherr T284 trucks on trolley anywhere in the world, and also the first Komatsu 930Es. There's some big trucks and it was great fun.
So that's some really good experience, I suppose, and unique experience, because I guess in the world, Trolley Assist's been around for a while, but it hasn't been applied at too many places in the world.
No, it hasn't. It's mainly in Southern Africa historically. Certainly in the last few years now, we're seeing it used coming in South America and North America, and a few Eastern European countries as well.
So given that we haven't implemented Trolley Assist, extensively throughout the world, there's obviously some challenges and hurdles for overcoming to make Trolley Assist worthwhile for an operation. What are some of those?
There's obviously a large capital investment required for Trolley Assist, so you're not going to put a Trolley Assist in for a small tonnage mine. You need substantial tonnage coming out of the pit. You need to be able to, you generally need to put a third haulage ramp in your pit for the trolley lane, so that the trolley trucks can operate uninterrupted at that faster speed when they're coming up on the ramp. So there's a large waste, generally a waste removal cost associated there with that extra lane. Additional electrical infrastructure. Obviously your power consumption at the mine goes up and your existing electrical mains may not be sufficient. There's a substantial DC rectifying substation cost to supply the power to the line. There's the actual line itself, not just the cost of the line, but also the time to construct that line. And then obviously there's modifications on the trucks that are required as well. You need a diesel electric truck that can then be modified for trolley. A straight diesel truck can't be used. So it depends on the type of trucks that you've got or are planning to purchase.
So is there a type of, like a type of mine or a orientation of mine that would best suit trolley?
Yes. You need a deep mine to really take advantage of the trolley. A typical Trolley Assist line is in the order of 7 to 750 metres long, and it can obviously be extended further into the pit, but a typical e-house electrical house will supply a 750 metre long line. You also need a ramp that's going to be in that position for a substantial amount of time, at least 3, 4, 5 years to justify the capital expense and the time it takes to put the trolley line in. So, a big copper open pit, a big iron ore mine, a deep iron ore mine. I don't believe many of our Pilbara iron ore mines are particularly suited because they're reasonably shallow. So, but yeah, certainly a big deep porphyry copper mine or something like that would be suitable for trolley assist.
And you're wanting to have, on a final wall or on that, so you don't want to be having a mine where you've got to cut back
Absolutely.
your pit multiple times.
If you can put your trolley ramp in on a final wall, that is first prize. That obviously doesn't always make sense with pit staging options, but I guess it's a trade-off. Certainly in Zambia, we did move trolley lines, so we moved them very successfully. But yeah, there's a time investment in there.
And I guess when we're thinking about we also think about the diesel cost to power cost ratio as being very important to this. So obviously the higher the diesel price, the more attractive this becomes because you're eliminating diesel, and the lower the power cost that you have.
Traditionally, if your power is coming from a hydropower plant and it's reasonably cheap, then it will make sense. There's no trolley assist in Australia because a lot of our mines are providing their own power. They're not connected to a hydro system. So your power is still pretty expensive. And in many cases, it's powered by diesel generation anyway. So that's probably why we haven't seen much trolley assist in Australia so far. But now with global warming and greenhouse gas reduction mandates that most medium to large mining companies are following now, there's a real benefit to reducing the amount of diesel that we consume in a mine, and that's a really strong driver now. You can see in mines such as Copper Mountain in Canada, Boliden's Aitik mine, they're all trialling and implementing trolley assist mainly to get their greenhouse gas emissions down.
Absolutely. So I mean, it's a dual benefit. Like if we could make it economically viable and you're connected to a renewable source, then it becomes, I guess, a dual win if you can get the conditions right.
I guess given the construction and implementation time for these sorts of systems, we need to look at what the regulatory environment is going to be in several years' time. Certainly in Europe, there's internal and external carbon prices that are going to be applied to mining projects, and this is one very valid way of reducing those emissions, and that carbon price will help justify this kind of upfront capital expenditure.
Absolutely. And I guess how would trolley work? Would it work or not work with other technologies like battery?
Absolutely. I suppose we've only been talking about open pit here because that's the main application at the moment. But yeah, battery electric haulage is an emerging field in open pit mining. And yeah, there's definitely application for dynamic charging of batteries while you're connected to a trolley line. So yeah, they can very definitely be used together. This is an emerging field where lots of research is being done at the moment, lots of simulation, lots of modelling to try and determine the best trade-off between static charging of batteries, dynamic charging of batteries. For example, people are looking at things like, can we put a trolley line in on a flat haul road rather than the traditional ramp, and see if that makes sense from a charging perspective. Are you better off to maybe slow your truck down, charge off the overhead trolley line, rather than losing stationary time at a static charger?
Yeah, I guess that's obviously something people are, grappling with at the moment, and maybe that technology could help with that, or find a new application that it didn't have before.
It's a really interesting field, and it's a really young field, and I think as a mining engineer it's really exciting to be involved in because we're having to really rethink the wheel and figure some things out from first principles.
And you touched on underground mining. So is trolley, has it been applied, or does it have application in underground as well?
Trolley has been applied underground. I'm sure many people have heard of Karuna trucks. don't quote me, but it's going back 50 years or so. Certainly at Mount Isa, where I worked as a graduate, we had an underground Karuna trolley truck line. They started out with overhead trolley lines on the decline incline, so they were hauling loaded up the decline. And then they had a very small battery that allowed the truck to leave the trolley line and get loaded just off the incline. That truck was then adjusted. It was actually converted from that very small battery to diesel, so that had a greater range off the decline. And I believe some of those trucks are still running in Canada. But the most recent lithium-ion battery trolley truck application has just been implemented and trialled at Beliden's Ravliton mine in conjunction with Epiroc and ABB. They've just done a very successful trial there, and they're planning on, after I believe it was a 750 metre test track, and they're now going to run the trolley line up the entire decline for this new ore body that's off their main deposit. So that's very exciting.
Yeah, and what are some of the challenges of that in underground mining that are different than open pit?
Well, I would say road quality is one. In open pit, you definitely need to have a pretty smooth road to make sure that you maintain a nice, smooth, even contact between the pantograph on the truck and the overhead line. Generally, underground mines, because of the slower speed that vehicles travel at, the roads are generally not maintained to the same standard. So that's one challenge that I can foresee. The other challenge is a safety one. You've obviously got live electrical wires much closer to the ground than you do in open pits, so there's a potential safety concern there. You might have to rethink your traffic flow, whether you want to close off access to that decline. Although there are technologies being developed now, such as Blue Vein, which is being tested in Queensland, where they've designed it so that there really is no way to touch that live wire. So that's a big safety advance that's coming in the next few years.
All right. So I guess things are really moving in that in some of those areas. So.
Yeah, it's super exciting, and I can't wait to be involved and see what happens in the next few years.
Absolutely. Well, I guess that draws this podcast to a close. So thank you very much, Sarah, for joining us to talk about Trolley Assist.
It's been great to be here. Thanks, Tarrant.
And if you'd like to listen to more of our Fresh Thinking by Snowden Optiro podcasts, you'll find them free on our website, Spotify, and most other podcast platforms. And if you enjoyed the podcast, please subscribe to our YouTube channel so we can keep you up to date with future technical podcasts. Thanks.